During the course of this module, we will take a look at the definition and basic functionality of a file system, terms related to file systems, formatting, deletion, fragmentation, metadata, types of file systems, FAT file system, and NTFS file system.
The main purpose of computers is to create, manipulate, store and retrieve data. A file system provides the machinery to support these tasks. At the highest level, a file system is a way to organize, store, retrieve and manage information on a permanent storage medium such as a disk. Most file systems maintain the physical locations of the file on an underlying data storage device such as hard disk drive in terms of fixed size blocks, which is the smallest logical amount of disk space that can be allocated to hold a file. File systems manage permanent storage and form an integral part of all operating systems. There are many different approaches to the task of managing permanent storage. It is important to keep in mind the abstract goal of what a file system must achieve: to store, retrieve, locate, and manipulate information.
Consider a street that has many houses, and every house has a unique house address. It is the job of a telephone directory to link the address of the house to the name of the person who lives in it.
Every sector in the hard disk drive has its own unique address, and much like the telephone directory, it is the job of the file system to link the file name and the sector address. Let us assume that this is a hypothetical file system. The file system assigns an index number to every file name and then links this index to the physical address of the sector where this file is saved.
Let us take a scenario where the system does not come pre-installed with an operating system. Here, during the formatting, a brand new file system is installed, and this helps the operating system to manage its own files too, along with the files that the user saves on the hard disk drive.
Just like the identity card offers information about the student's roll number, address, contact number, blood group and stream, metadata offers information about the file's date of creation, last date modified, user created, its size, security and permissions. It is essentially data about the data. Let us see what happens when we try to save a big file. As you can see, this file does not fit into any one single sector. This file is then broken up and saved in multiple sectors. This process is called fragmentation. The accessing of this file takes more time as it is stored in multiple locations, and the file system first accesses all locations, compiles the file and then opens it. Let us assume that the data in red is about to be deleted. When we try to delete this file, what actually happens is that the entry in the file system corresponding to the file is scratched out. The file, however, still remains on the hard disk and can be recovered using recovery software.
Mainly there are three types of file systems. The first one is disk file systems. A disk file system takes advantage of the ability of disk storage media to randomly access data in a short amount of time. Additional considerations include the speed of accessing data following that initially requested and the anticipation that the following data may also be requested. This permits multiple users or processes to access various data on the disk without regard to the sequential location of the data. Some examples of disk file systems include New Technology File System, Extension File System, and Hierarchical File System Plus. The next type of file system is network file systems. A network file system basically is a file system that acts as a client for a remote file access protocol. Protocols can include File Transfer File Protocol or HTTP. It provides access to files on the servers concerned. The examples of network file system include clients for the NFS or network file systems, AFS and CIFS, a common internet file system. The third category of file systems are flash file systems. A flash file system considers the special abilities, performance, and restrictions of flash memory devices. Frequently, a disk file system can use a flash memory device as the underlying storage media, but it is much better to use a file system specifically designed for a flash device.
Disk file systems. In majority, there are three dominant disk file systems. First one is NTFS. NTFS was introduced with the Windows NT operating system. Other features also supported by NTFS include hard links, multiple file streams, attribute indexing, quota tracking, sparse files, encryption compression, and reparse points. Second one is ext4. The ext4 or fourth extended file system is a journaling file system for Linux developed as the successor to ext3. It is mostly used in the various versions of Linux. Third one is the HFS Plus. HFS Plus is a file system developed by Apple Incorporated to replace the hierarchical file system as the primary file system used in Macintosh computers.
FAT file systems. The file allocation table or FAT file system was initially developed for DOS operating system and was later used and supported by all versions of Microsoft Windows. The FAT file system is a legacy file system which is simple and robust. It offers good performance even in lightweight implementations. The successive major versions of the FAT format are named after the number of table element bits: 12 for FAT12, 16 for FAT16, and 32 for the FAT32 version of the file system. FAT12 file system. Cluster size is limited to 8 kilobytes. It has 12-bit addresses for clusters. FAT16 file system. Cluster size is limited to 32 kilobyte. It has 16-bit addresses for clusters. FAT32 file system. Cluster size limited to 32 kilobytes. However, only 28 of the 32 bits are used for cluster addressing.
Windows developed a brand new operating system, Windows NT 3.0, and to go along with it, it developed a brand new file system, NTFS. Let us now look at a few features of NTFS. One of the most important features of NTFS is Access Control List or the ACL. Here, the owner of the file can choose which users can access his files and what permissions each user can have. NTFS has a feature called encryption, which allows encoding the data and thereby keeping it secure.
This feature helps to reduce footprint size of the data, thereby reducing the overall memory. Another special feature of NTFS is called as cluster remapping. It is an important feature that tries to minimize loss of data. The file system automatically detects when a cluster is bad, copies the data to a healthy cluster, and then marks the cluster as defective, ensuring that data can no longer be written to it.
There are two copies of MFT stored in the hard disk drive, one at the beginning and the other in the middle approximately. This ensures that accidental deletion or an accidental corruption of one MFT does not mean that data is lost.
NTFS also helps to reduce fragmentation levels by ensuring that each time a new file is saved, some extra space is stored along with it, called padding. This ensures that the file has space to grow, and it does not remove fragmentation, only reduces it. The books in this bookshelf can be thought of as files or data already stored in the file system. As existing files are modified or new files are created, more books get added to the shelf. However, older versions of the books that are already present do not get removed. This is what journaling is all about. All saved versions of the file along with the latest version are all saved. Thus the user can go back to a particular stage of the file in the event that an event crash or any file corruption occurs.
Summary. A file system is a method for storing and organizing computer files and the data they contain to make it easy to find and access them. Its main function is to link the file name and file index to the physical address of the sector in which the file is stored. It is structured in a sequential and hierarchical manner of comprising files and directories, reformatting, deletion, and fragmentation in the file systems. The metadata of each file stored in the file is actually data about the data. The three main types of file systems are disk file system, network file system, and flash file systems. FAT and its various versions, FAT12, FAT16, FAT32. NTFS and its features like file permissions, encryptions, compressibility, cluster remapping, recoverability, reduced fragmentation.